down again. You know, I was gonna film right there. I don't know if that's gonna happen now. I interrupt our normal chronological storytelling about what sentences I'm choosing to bring you this cool little short story that it happened recently. It's not like in order of the sentence selection. This happened like last week. Woo! Little bit of an outing today. The rest of the research group and myself, Maris, are visiting Sea Technology Services or something like that. Go check them out. And apparently they're a company that developed hardware for boats. I don't know where they've been. It's kind of my job, and it would have been nice to know of their existence. But I'm here at the gorgeous V&A waterfront in Cape Town, and as I was parking, I saw a little guy just peeping around the corner, scoping me out, saying, "Hey, come here, I want to meet you." It's the boat that hopefully, maybe, fingers crossed, I take to Antarctica. Hey, little guy. It's probably offensive to call that thing a boat. It's a ship. It's a ship.
Come down to her, see what we've done. Is it too late to sail in a new direction?
Snowmobile. Ooh. Kind of surprised you.
So we've got a fleet of robots that we manage for them. And then we also develop sensors and other things that we'll show you in the lab. Does anybody know what a float is?
When Veritasium or any of those cool guys make a video like this, they are there for the express purpose of filming. And I felt hella kind of awkward being there, like, what did you say that was? So I took some footage, jammed together what I thought was cool. I'm gonna do some voiceovers, and explain how these things worked, and hopefully you guys enjoy it. So this company mostly seemed to operate by working with researchers who said, I want to measure these specific things, and then they would go ahead and build the hardware needed to measure those things, just like me. More specifically, they seem to pretty much build floating things that collect data. Because of that, a certain requirement that they have that I don't is that their hardware has to run off very little power. Using its sail, this little guy uses the wind to direct itself and collect data on the surface of the water. By using the wind, this little robot saves the battery power for collecting data rather than trying to get about. The engineer there said that this was a dumb robot and there were way more efficient ways to save energy. So if this is the ocean water and we drop my boy Planky in there, he's gonna more or less just float, sink all the way down. But if we add wings to Planky, Planky's gonna move along at an angle. The question is, how do we get Planky back up so that he can continue moving at this angle? We were shown two different sets of platforms that made use of this principle. The first platform that he showed us was called the Wave Glide, and this basically consisted of a surfboard, flotation device, thingamabobby. This carried all the sensors and hardware and the data collection stuffies, and underneath it hangs this heavy platform that contains these fins that stick out to the side. The surfboard sits on the surface and the fins sit down underneath, tethered by a cable. When a wave comes, it lifts the surfboard up, which is then attached to this set of fins, which also goes up. And as they move up through the water, they get angled in a certain direction. As they get pulled upwards through the water, that angle causes the surfboard to move forward. And then when the surfboard sinks down on the other side of the wave, fins angle the other way and continue this gliding motion. So the problem that I showed you earlier with how do we reset the fins such that they can continue moving through the water is it's simply done by the waves. Now these guys are kind of the goats of efficiency. All the power goes to the sensors, and in fact they hold a Guinness World Record. A wave glider made by Liquid Robotics traveled 17,000 kilometers over 31 days on a data collection journey. God damn! A limitation of this is what happens if you want to measure currents deep under the surface. We were then introduced to the SOCOM glider made by Teledyne. And as you'll find in due time, I have certain feelings about that company. This glider was made specifically to deal with this problem. Basically, it was a little torpedo looking thing with little wings on the side, and all the sensors and electronics were built inside of it. The key component was its external oil bladder. Quick little lesson on buoyancy. Buoyancy is the upward force that an object experiences when it floats in water. That force is directly proportional to the amount of that fluid that object displaces. So the more fluid an object displaces, the more it wants to float. By inflating and deflating this bladder, it can control its volume and therefore its buoyancy. Inflated bladder, big volume, float. Deflated bladder, small volume, sinks. So when it's at full depth, which is roughly 1,000 meters down from the surface, it inflates its bladder and begins to float. But because of its little wing, it floats at an angle all the way to the surface. It's got a little antenna in its tail that transmits some data to a satellite, and then it deflates the bladder, begins to sink. But again, wings glide. It can travel about 1,500 kilometers on a single charge, so it's no wave glider, but it's pretty good. So instead of having to power some hungry motor and spin a propeller, they just simply inflate and deflate a bladder, which is way more efficient. I just thought this concept was so cool. It's time to get political. So one of the recurring themes in research is someone develops a piece of technology and goes, wow, look at this. And then the military comes and goes, but can it kill someone? And then the researchers go, maybe. Okay, I'll buy it. And then they just make it inaccessible to all of us. They hide the code, they hide the designs, and then we just can't develop on it. So, some of the work that C Technology Services was doing was taking a platform that was previously used for military type of reasons and then deconstructing and reverse engineering the code so it could once again be used by researchers. Of course, they are not the only company doing this. While we were there, they showed us what was called the Spotter platform made by SOFAR. What this was a rough template of hardware for researchers to equip and attach their own sensors to. It had its own power system, it had solar panels, and maybe a few basic components. But basically the goal of the project is to make research hardware more accessible to more researchers. One of the pieces of hardware that they showed us that didn't involve just floating in the ocean was called the laser monkey sled, or monkey laser, or something like that. I'll cut to the actual name. But this was a DSLR camera in some serious waterproofing, just stuck to a metal rig, sunk deep down into the bottom of the ocean, pulled behind by a boat. The interesting thing was how it got depth information using a single camera. Placed all around the camera were 3 laser pointers. And they constantly shined while the camera was taking footage. By taking some calibration data of objects at known distances away from the rig, you can develop a relationship between where the laser pointers are on an image and how far the object is away. laser points close together, object far. Laser points far away in the image, object close. Get me, brother? See.
Could we easily pretend to be friends for the few years left? Don't give up.
UCT has some mobile labs that they can put on this platform. That little circle is a spinning lens, like the type I'm going to make, that helps them see when the conditions are bad. So there is where I'm putting my sensor suite, which is so much higher above the ocean surface than I thought it would be. Well, too late now to redesign. Let's hope it works. Hello! I hope you enjoyed that little detour. Listen, the next video is going to be a week late, but there's a good reason for that. I'm going on a ship. Not that ship, a different ship. So the next video may also be a detour about said ship.